Hello, my name is Camilo Acosta. My group is made up of Sebastián Rativa, Heider Villalba, Daniela Patiño, and Ricardo Triana. And today we are here to introduce you to the heat mechanical equivalent laboratory. Next, please. Okay, thermal visuality container contains a certain amount of water with a thermometer to measure its temperature. Analysis with vanes that are set in motion by action of waving a shower as shown in the figure. Next, please. Let you know, the original version of the experiment consists of two equivalent vanes hanging symmetrical from the axis. Next, please. The way which is moving white practically constant speed loss potential energy as concentrates the water heated by the bottles becomes warm due to friction. Next, please. In the block of mass M, the sense of hang H. The potential energy discerns be mg and h. And this is the energy used to heat the water. Other losses are neglected. Next.
Talking the simulator in an initial way, we can obtain the following data. The mass of the block is 250 kilograms. The 18 of the block to the ground is 3.5 meters. The specific heat of water is 4,186 joules per kilograms per coulomb. We have to calculate the mass of water with the density formula since of WAF its volume is 245 milliliters. We will find the difference in water temperature. Next, please.
What is the temperature differential? Mass of water, white density equation where within the mass of water be clearly the mass is the use that water has mass of 2.45 times the minutes for kilograms. Next, please. We find the potential energy that is stored in the block is calculated by the equation which tell us that potential energy is equal to a mass times the gravity times the A and gives of 8.575 joules. Next book. The temperature differential is clear and replacing the data gives 8.36 coulombs. Next. We take the initial temperature and add the temperature difference, which gave of 70.47 which is very close to the temperature of excited. Next.
And conclusion.
In total, there are 8 conclusions. The first 4 are: number 1, it can be shown that there is a quantitative relationship between the mechanical work done and the amount of heat produced. Number 2, the experimental value of the mechanical equivalent of heat can be determined from the amount of work done and the amount of heat produced. Number 3, the experimental value of the mechanical heat equivalent obtained is a measure of the efficiency of the process, time any mechanical energy not turned, so heat loss to friction or other energy losses. Number 4 is the accuracy of the mechanical heat equivalent measure depends on the accuracy of the temperature mass of heat measurement as well as the accuracy of the applied force. Therefore, it is important to use accurate or properly calibrated measuring instruments to obtain an accurate measurement of the mechanical heat equivalent.
Okay. And secondaries, mechanical work is form of energy that going to be converted in the height because of using the amounts of mechanical work required to produce it and work Amazon head we can conclude ten what 10 has to 14 energy are related to the conversion from mechanics to thermal energy is not perfect. It is possible what to mechanical energy is lost and head due to questions of from and energy dissipating 24 and the constant of the mechanical laboratory equivalent of the German everything depending and most is 3 the mechanical laboratory equivalent is system depends constant the amounts of mechanical work required to produce on 1 oomph of air might vary according to the specific properties of system under consideration. Conversation and sport of energy of threat. They all what follow a conversation of energy stirs and neither be created nor destroyed or transformed. Experiment to determine mechanical equivalent of the laboratory but if what the law is fully bet in the conversions of mechanics and math energy. Thank you and bye.